In this problem, we have given at a given instant there are 25% undecayed radioactive nuclei in a sample. After 10 seconds, the number of undecayed nuclei reduces to 12.5%. Calculate the mean life of the nuclei and the time in which the number of undecayed nuclei will further reduce to 6.25% of the reduced number. Okay. So first of all, at any instant we have given, and there are 25% of undecayed nuclei. So consider X is converting into Y, and X is 25% and Y becomes 12.5% in a given time of 10 seconds. That means the number of nuclei becomes half in 10-second time. So from here we can say that the half life T is the half life of this system is 10 second. Okay, and we have to find the mean life of the nuclei. So as we know that mean life is equals to 1 upon lambda. Okay, and half life is equals to ln2 upon lambda. So from here lambda will be equals to ln2 upon t. So now put the value of lambda over here. So 1 upon lambda is ln2 upon t. Okay, so over here we can write this will be equals to t upon ln2, and t is given as 10 second. So 10 upon 0.693. So mean life of radioactive substance will be equals to 14.43 second. This is the first answer of this problem. Now in the second part we have to find that the time when the number of undecayed nuclei will further reduce to 6.25%. Okay, so consider initially there were 100% of nuclei. So in a half life of time, that is in 10 seconds, it will be reduces to 50%. In another half life of time, that is 10 seconds, it will be reduces to 25%. In another half life of time, that is 10 seconds, it will be reduces to 12.5%, and another half life of time, that is 10 seconds, it will be reduces to 6.25 second, that is 6.25 second. Okay, so from 100% to 6.25 second, the total time elapsed will be small t, that is equals to 10 second plus 10 second plus 10 second plus 10 second, that is equals to 40 second. So the answer of the second part will be 40 second is the answer of this problem. Thank you.
Hello everyone, let us start with our question. In this question, what is given? That a small quantity of solution containing Na24 radionuclei half-life is given of activity 1 microcurie is injected into the blood of a person. So this is injected into the blood of a person. Now a sample of blood of volume 1 centimeter cube taken after 5 hours shows an activity of 296 disintegration per minute. Okay, so when we are taking a sample of blood, it is showing a disintegration of 296 disintegration per minute, but it is given as per minute. Now determine the total volume of the blood. Total volume we need to find of the blood in the body of the person. Assume that radioactive solution mixes uniformly in the blood of a person. So it is mixing uniformly, and what is given? It is given that 1 curie we need to take in terms of disintegration per second as 3.7 into 10 to the power 10 disintegration per second. That means this 1 curie, this initial disintegration should be multiplied by this initial in curie disintegration in curie should be multiplied by initial activity should be multiplied by 3.7 into 10 to the power 10, so as to get the disintegration per second. Okay, so what would be the initial activity R naught? Initial activity R naught, how can we write? It is directly given as 1 microcurie. So we can write it as micro means 10 to the power minus 6, and what is curie? Curie is given as to be 3.7 into 10 to the power 10 disintegration per second. So what would be this value coming? This value would be equals to 37000 disintegration per second. Now, since we are also knowing the half-life, which is equals to 15 hours, so what we can find? We can find the value of lambda. So lambda would be, how is lambda defined? Lambda is 0.693 divided by t1 by 2, t half-life, and t, so basically it is ln divided by t, so ln could be written as 0.693, so it would be 0.693 divided by half-life, this is 15, and we can write this value as 0.462 per hour. So this is the value of lambda. So we are doing the initial activity and we are knowing the value of lambda. Now it is also given that the sample of the blood of volume 1 centimeter cube. 1 centimeter is showing an activity of 296 disintegration per minute. So it is showing disintegration per minute in terms of 296 disintegration per minute. So what we should do? We can just convert it into the terms of same unit as equals to disintegration per second. So it is given that small r value is given as to be this value is 296 disintegration per second. So what would be the this is for 1 centimeter cube. This is the activity for 1 centimeter cube. So for example, if the volume is V, what will be the total activity? Total activity for V centimeter cube. If the volume was V centimeter cube, what should have been the total activity? This is for 1 centimeter cube. So we just need to multiply it by, sorry, we have just done one thing. So it was disintegration per minute. So it is given as disintegration. We can just rewrite this. Okay, we can just rewrite this step. So it was given as 296 disintegration per minute. Okay, so if you were to convert this into second, so we can write 296 divided by 60 seconds disintegration per second. So what is the value of small r? Small r value is coming out to be, if you were to just divide it, it would come out to be 4.933 disintegration per second. Now this value is for disintegration per second. Now this value is just for a sample of 1 centimeter cube. 1 centimeter cube, for a sample of 1 centimeter cube. Now for example, the volume, total volume is capital V. So what would be the total activity? Total activity of V volume of V centimeter cube. Okay, that would be equals to V multiplied by this. So it would be 4.933 into capital V centimeter cube. For example, capital V is the volume of the total. Now how we can write all the relationship between this total activity and initial activity? What is the relationship? So R is equals to, this could be written as R, this is R. So R could be written as R naught e to the power minus lambda into t. So this was after 5 hours. Okay, we know that this is the activity after 5 hours. This is the activity after 5 hours. So we can write it as 4.933. And what is the value of R naught which we have calculated? R naught value we have calculated as, let us check what is the value of R naught which we have calculated. R naught value is 3700 disintegration per second. So we can write it as 37000 disintegration per second e to the power minus, so it is V here. Lambda value is, we have just calculated, lambda value is 0.0462. And what is this activity after how much time? This is the activity after, I guess, 5 hours. So we can just multiply it by 5. We can multiply it by 5. So what would be the value of V which would be coming? It is 37000 e to the power, this factor has a value of 0.793 divided by 4.933, and the total volume which would come out to be, V volume, would be 5953.44 centimeter cube. So this is the total volume. So let us check what we were to find. We need to find what is the total volume of the body. So total volume is coming out to be, it is coming out to be 5953.44 centimeter cube. So hope you have understood the solution. Thank you.
हेलो एवरीवन, इस क्वेश्चन में हमें स्ट्रीम दे रखी है न्यूट्रॉन्स की, जिनकी काइनेटिक एनर्जी की वैल्यू है 0.0327 इलेक्ट्रॉन वोल्ट। अगर हम बोला है कि न्यूट्रॉन की हाफ लाइफ है 700 सेकेंड्स, तो हमें बताना है कि कितना फ्रैक्शन ऑफ न्यूट्रॉन डीके हो जाएगा जब वो डिस्टेंस ट्रेवल कर लेंगे इक्वल टू 10 मीटर। और हमें मास ऑफ न्यूट्रॉन गिवन है 1.675 इंटू 10⁻⁻27 kg। हमें पता है फ्रैक्शन ऑफ न्यूट्रॉन्स अनडीकेड की वैल्यू होती है n बाय n नॉट, तो फ्रैक्शन ऑफ न्यूट्रॉन्स डीकेड की वैल्यू जाएगी 1 माइनस n बाय n नॉट। और हमें पता है कि n बाय n नॉट की वैल्यू होती है इक्वल टू 1/2 टू द पावर स्मॉल t बाय t। और हमें कैपिटल T की वैल्यू गिवन है इक्वल टू 700 सेकेंड। हमें स्मॉल t की वैल्यू निकालनी है, उसके लिए हम यूज़ करेंगे काइनेटिक एनर्जी का फॉर्मूला, जो कि हमें बताया हाफ इंटू एम इंटू वी स्क्वायर इक्वल टू 0.0327 इलेक्ट्रॉन वोल्ट, ये हमें गिवन है। तो काइनेटिक एनर्जी को जूल्स में लिख लेंगे और मास के लिए सब्स्टिट्यूट कर देंगे, तो हो जाएगा हाफ इंटू मास ऑफ इलेक्ट्रॉन है न्यूट्रॉन है 1.675 इंटू 10⁻⁻27 इंटू वी स्क्वायर इज इक्वल टू 0.0327 इंटू 1.6 इंटू 10⁻⁻19। इससे जो हमारा वी स्क्वायर है उसकी वैल्यू आती है इक्वल टू अंडर रूट ऑफ 2 इंटू 0.0327 इंटू 1.6 इंटू 10⁻⁻19 डिवाइडेड बाय 1.675 इंटू 10⁻⁻27। इससे हमारा वेलोसिटी का निकल के आती है इक्वल टू 2.5 इंटू 10⁻³ मीटर पर सेकेंड। तो इससे हम टाइम की वैल्यू निकालेंगे, तो टाइम की वैल्यू जाएगी इक्वल टू डिस्टेंस अपॉन स्पीड। तो हमारा डिस्टेंस है 10 मीटर डिवाइड बाय स्पीड, जो कि हमें पता है 2.5 इंटू 10⁻³। इससे हमारे टाइम की वैल्यू निकल के आती है इक्वल टू 4 इंटू 10⁻³ सेकेंड्स। अब इस टाइम की वैल्यू को हम n बाय n नॉट के फॉर्मूले में सब्स्टिट्यूट कर देंगे, तो हमारा जो आंसर है वो हो जाएगा इक्वल टू 1 माइनस n बाय n नॉट विच इज इक्वल टू 1 माइनस 1/2 टू द पावर, टाइम की वैल्यू यहाँ पे सब्स्टिट्यूट कर देंगे तो ये हो जाएगी 4 इंटू 10⁻³ डिवाइड बाय 700। इससे जो हमारा एक्सप्रेशन है वो हो जाता है 1 माइनस 0.999952 और हमारा फाइनल आंसर निकल के आता है इक्वल टू 0.000048, जो कि हमारा करेक्ट आंसर है।